Guys, welcome to my channel. So in this video we're going to look at Sieve of Erathosthenes. Now let's say a question is asking you count the number of prime numbers from 1 to n can be 100 in this case. Now a naive approach to this problem would be to have a function that is going to tell you, that is going to check if a number is prime or not, and then you're going to run a loop from 1 to n, and you're going to check it for each number and increment a counter accordingly. So that is a naive approach, and it's going to work for some cases. But let's say the input is really large and it's 100,000, then it's going to give you an error based on how harsh the time constraints are. So you might want to look for a better algorithm. So we're going to go for Sieve of Erathosthenes, and I'm just going to refer to it as Sieve from now on. So first of all, before we implement it, and as we implement it, we're going to initialize a Boolean array, and it's going to be of size n plus 1. So in this case, the n is 100 and it's going to be of size n plus 1, which is 101. We do that to keep the natural counting in order, right? So then we're going to have a loop, and it's going to mark every single element or indexes from 2 to the last index as true. So it's going to set every one of the indexes as true. We're basically assuming that all of them are prime numbers, right? Then we're going to have the main component of the function, and it's going to have two loops. The outer loop is going to declare or tell us a prime number. So we're going to select a prime number, and then we're going to mark all of the multiples of that prime number as false. And why we do that? Because if a number is a multiple of a prime number, it cannot be a prime number, right? So that's why we mark it as false. Now the outer loop, let's say it selects 2, because we're gonna run from 2, so it's gonna see that, oh, true is actually set to true, 2 true, whatever. And now we're gonna mark all of the multiples of 2 as false, 4 as false, 6 as false, 8 as false, 10, 12, 14, 16, and whatnot. So I'm not gonna run through the whole list of elements, but you get the point. Now we're going to come to 3, and it says, oh, 3 is also marked as true, so it's got to be a prime number, and now we're going to do the same. By the way, in the second loop, we're going to initialize the second loop from the square of that number, of the prime number. So for 2, we're going to initialize it from 4 itself, and for 3, we're going to initialize it from 9, because the rest of the elements are already being taken before 9 is going to be taken care by 2. So for 6 is a multiple of 3, but 6 has already been taken care of by 2 anyway, so we're not going to bother with that, and we're just going to save a little bit of time by starting it from here. Now it's going to start from 9, it's going to set it to false, and 15, and 21, and so on and so forth, right? So we're going to do the same thing for 5. By the way, it's going to come to 4, and 4 is not a prime number because it's set to false by 2, so we're just going to skip it and go to 5. And then 5, it'll initialize it from 25, and we're going to start it from 25 onwards, and we're going to do the same. And at the end, what we're going to do is we're going to have an array with some true and with some false elements. And so the false elements are not prime numbers, they're composite numbers, and the prime numbers are going to be set to true. So we're just going to increment the counter every single time we come across a true element, and we're going to just have the number of prime numbers from 1 to n. So let's try to implement it, and we're gonna come across some optimizations, and we're gonna discuss it later on the whiteboard itself, right? So let's try to code up the function, and it's gonna be static, and let's call it sieve, and it's gonna take an argument of the n, so 1 to n, right? And let's try to initialize the array that we're talking about. So Boolean, let's call it temporary, yeah, and then the number of elements would be n plus 1. So yeah, there we have it. Now what we gotta do is we're gonna have a loop, and it's gonna be starting from 2, second index, and it's gonna run till the n I plus plus, and it's gonna set all of the indexes to true, right? So temp I equals true. So we talked about this in the whiteboard while we're doing this. So we're just doing this so we can assume all of them are true. So in the next component, as we as we'll see, we can just then we can test if a number is prime or not. So that's why we do this at first, right? So then we can now code up the main component. So let's start from int I equals 2. We're also going to start it, initialize it from 2 because 2 is the first prime number. We're not going to bother it with anything else. And I less than equals to n and plus plus. And by the way, in here we can do a massive optimization because we're not going to run the whole loop till n. We can just run the whole loop till square of n, like so I mean not square of n, like root of n. So square root of n to be exact. Why we're doing this, right? So if a number is a multiple of a prime number, the prime number is not going to be larger than the root of that number. And we can actually mathematically prove that, but we're not going to do this in this video because it's going to be long, but I'll try to do it in another video. But that's we can mathematically prove that, right? So let's say we're trying to find if 25 is a prime number or not. It's not, we can tell. So we're not going to check it till 25 to find, we're not going to run the loop till 25 to find out if it's a prime number or not. We can just run it till 5, which is the square root of 25, and we can just check it like that, because if there is a prime number that is going to be dividing 25, is going to be less than or equals to 5. So in this case, 5 is going to divide 25, which is equal to the root of 25. So I hope that is clear. It's pretty easy to understand. Now let's go back here. So we'll just do it as I squared. So we're just basically running it to square root of n. So you know about this if you have coded the function that checks if a number is prime or not. So you know that you only run it to root of n. Now we're gonna check if temp phi, if it is true, then only. And by the way, if you don't know what we're doing, so we're just checking if it's true or not. So we're just not gonna bother with this. If it is true, then we're gonna do some stuff. We're gonna check, like we're not gonna check, we're just gonna make all of the multiples of that prime number as false. So we're gonna have another loop for int j equals 2. I mean not 2, it's gonna start from the square of that number, square, and it's gonna run through the whole thing, and j plus equals I. So why did we do this? And we know why we did this, because we're not going to bother with anything that is less than the square of that number, because it's already going to be taken care of by other prime numbers that is going to appear before it. And why we did this, because we're just going to keep on making the multiples of that number false, because from 3 we're just going to jump by 3. So 9, from 9 we're just going to go to 12. From 12, we're just going to go to 15, because anything between that is not going to be divisible by 3 anyway, so we're not going to bother with that. So that's why we do this, and we're going to mark it as array j equals false. And now we've done all of the things, and now the rest of the things are pretty simple. It's just one little component. So for int I equals 2, less than, we're just running through the whole array once again, and we're checking how many elements are actually true. So the true elements that are going to be left, they will be the prime numbers, right? So I plus plus, and if temp, sorry by the way, this is going to be temp because our array is temp sure, temp I, then we're just gonna increment a counter. Let's count equals 0, and we're just going to return the counter after that. So that's basically it. And now let's try to test it. Let's call it, and we're also going to print it at the same time. Print Sieve, and let's try to pass in 100, and let's try to check if it works or not. And so okay, spelling is wrong. Let's try to run it again, and it gives us 25, which is correct. So there are only 25 prime numbers till 100, and let's check it for 1000. Let's check if it runs. and there are 168 prime numbers, which is also correct. You can Google it. So our function is running fine. Now let's run through this once again, right? So we declared an array of Boolean, which is going to have the length of n plus 1, and then we declared, or we set all of the indexes of that array from 2 to the last index as true, and then we run the main component. We run the outer loop, which is going to start from 2, and it's going to check if the number is true or not. If it is, then it's a prime number, and then we're going to set all of the multiples of that number as false. And then we're going to do that for the rest of the elements, and we're just going to run the outer loop for root n amount of times. And then we're just going to have the last component, which is going to basically check, as a simple component. It's going to check if how many true elements there are in the array left, and it's going to increment the counter accordingly, and we're just going to return the count afterwards. So pretty basic, and the time complexity of this algorithm is n log of log n, which is much better than the previous algorithm what we usually go for, right? So that was it, guys. If you found this helpful, please leave a like and leave a comment, and also share this with your friends. Thank you and have a great day.